pass the floor over to Anne Pereira, who is going to tell us, who's going to moderate this session on radio waves and the brain. So Anne Pereira is a researcher on neurosciences at the University of Strasbourg, and she also works with ANSES because she is a president of the expert committee at ANSES. I suggest that we start this second session similarly on the same. We're going to try and respect our timing. We have Giuseppe Curcio, who is from the University of Aquila, who is a professor of cognitive and behavioral psychology. And there won't be, we'll take no questions directly, but afterwards, but we'll save the questions for at the very end. Thank you very much. I'm sorry, but I don't speak very good French, so.
So, thank you for this invitation and for this opportunity to discuss with you, trying to summarize what happened in the last 25, 28 years of research on the relationship between radiofrequencies and the brain. Why in the 90s? Because in that period, this research field was born as a reaction to worries of public opinion about possible harmful effects of radiofrequencies over the brain functioning. And this coincided with the spread of mobile telephony when we started to bring radiofrequency devices very close to the head. And this closeness convinced that there could be a possibility that radiofrequency can interfere or at least modulate cognitive functioning. As you can see, there are a lot, an explosion of literature after the 90s. And the reason for which we are so interested is also because independently by work, activity, and age, now we are used to use these devices. When we study brain functioning, we can look at different outcomes. For example, cognition or behavior, or waking EEG activity, or sleeping EEG activity. Obviously, I try to summarize just to give you just some example of studies published in this period, because 25, 28, 38 of literature is a very rich literature and we have no time. What about cognition and behavior? As a first, we have to say that we can assess cognition and behavior in several ways. We can look at attention. The colleagues from Belgium, from Brussels before say that they test attention. Memory, learning, ability to navigate, decision making, and so on. And we can use both computer-based tasks and paper and pencil tasks. Basically, we look at two different dependent variables. Speed, that means the time you need to accomplish the task, to complete the task, and accuracy. So basically the number or percentage of correct responses or errors that you commit when you do a task. This is one of the very first studies, 1999, by the Priest and colleagues, that tried to assess cognition and behavior under the effect of exposure to radiofrequencies. The setting is quite similar all over these 25 years. We have a radiofrequency emitting device that is located very close to the head. And in this case, they used a very big battery of tasks that test different function of the brain. Attention, vigilance, mental arithmetics, ability to respond to stimuli, to external stimuli, and so on. The results is that between 15 more or less tasks, just one was statistically significant. And they concluded that the exposure to radio frequencies induce a speeding up of performance. So this was particularly true with the analog signal. Do you remember the old signal we used before the GSM with respect to the digital radio frequency exposure? Other groups, this is a work, another seminal group by the Finnish group by Koivisto and colleagues, used a similar setting and tested a similar variety of cognitive tasks. When the field was off and when was on. And the effects are indicated by the arrows. Just 3 out of this function were significantly improved. This is the trace is improved in the presence of of a radio frequency source. We too, in our group, the same setting as you can see, did the same. And using some similar task, we were able to find a speeding up of reaction times. The red one was the time to accomplish this task when the radio frequency was on, when was off, and when there is no radio frequency at all, without the casque, without the helmet. And the same for the choice reaction times. And we concluded that facilitatory effect is present on both vigilance and attention. Going back to what said Emilie van Deventer before, we tried to replicate this study. I was one of the experts of the panel of WHO, so I participated in the first step of a selection of studies who were replicable, that were reliable, that were methodologically sound, together with, for example, René Desets. And the trouble starts when you try to replicate this data on cognition and behavior. When you do it, and as you can see, it's the same group that before showed that a facilitation of cognition under radiofrequency exposure, found no effect at all. Well, this is just a chance. It can happen. Okay, we did the same with a similar setting, as you can see, with a similar task, and again with some methodological improvement, as Harala did in the previous study, we observed a similar absence of effect. So again, the data were not replicable. So what we can conclude from the cognition and behavior section of radiofrequency exposure, as several reviews and meta-analyses said, this is one of my group, this is from other colleagues, this is mine some years ago, we can say that radiofrequency do not seem, on the basis of the reliable and replicable literature, to be able to change consistently the cognition and performance on human individuals. Probably the difference are motivated on the basis of a different methodology, statistical power used in the studies. The expert of epidemiology can teach to me this, how important is this issue. And then the way in which we interpret this data. So the effect on cognition and behavior are small and usually not relevant for the functioning of the brain. What we can say about EEG? As a first, EEG is a non-invasive neurophysiological measure that is recorded from different places over the head, from the electrodes, that can divided in different frequency band, from the lower and slower up to the fastest one, and can give us the functioning, a reflection of the functioning of the cortical neurons. So we don't know what happened under the cortex with the EEG. We can just estimate it. What can we say about sleep? Sleep uses the same, a similar technology, but give us the opportunity to score the sleep between REM sleep and non-REM sleep. REM sleep when we basically dream, and non-REM sleep when we recover and restore from the past day. And what can we say about these two different outcomes of brain functioning? This is one of the first studies by the Australian group by Rodney Croft on the on the EEG, and they found an increase, a significant increase, in several points of the head in the alpha range. As you remember, before we have seen that the alpha range is one of the frequency of our EEG. And they concluded that the active mobile phone can affect neural function as a function of the exposure to radiofrequency, basically on the alpha range. We too observed something similar with the same setting you have seen before. We observed again an increase in some beams of EEG, namely in the alpha. And we concluded again that the alpha is the most sensitive portion of our EEG. Again, the Swiss group coordinated by Peter Ackermann, the same effect on the alpha, and they concluded that the spectral power of the EEG, of the waking EEG, was increased in the alpha range. Can we conclude something about the studies on EEG? We can conclude that, as we did in this review that you see here, but also in order by the group from Australia, coordinated by Rodney Croft, but also by the group of Ineris, if I will remember, with this review by Wallace and Selmawi, that basically there is more consistency of EEG studies of waking, and alpha range seems to be very sensitive to the effect of radiofrequency, both under the exposure and at the end of the exposure. So this effect lasts for a while, not so much, but for a while, in order of minutes, I mean. Finally, the last step is looking at the sleep studies. What we can say, this is one of the first studies on sleep. They assessed both the amount of different stage and phase of sleep, and both the intensity of EEG, the power spectrum, and their conclusion was that after exposure, sleep latency and REM sleep percentage were reduced. So there were a kind of hypnotic effect. You are under radiofrequency and you should fall asleep before. But at the same time, they highlighted that all frequency bands resulted increased. Again, another study is by the Swiss group, coordinated by Borbeli and Ackermann, and they found a similar effect. Again, alpha range is very sensitive and very responsive to the presence of radiofrequencies. This is the conclusion. And again, another study, the Swiss group is a group very strong in the field of sleep psychophysiology, so they carried out a lot of studies on sleep, ever concluding the same. That means there is an increase in alpha and a decrease in sleep spindle when we expose to radiofrequency, as you can see in the first 30 minutes of sleep. So this effect is limited in the time. So can we conclude something about this example of studies in the field of sleep? One study from us is a chapter on a book, and another from other expert of sleep on sleep medicine reviews, basically says that also in sleep, as in waking EEG, alpha, and in this case sigma band, seems to be very sensitive to radiofrequencies exposure. Obviously, I here today discussed with you just of a limited portion of the literature. I didn't discuss event-related activity, for example, evoked potentials, or neuroimaging studies that are a lot of studies, very interesting, and that give us the opportunity to look inside the head. But anyway, we can say that, summarizing, cognition and behavior, few, very very poor consistence. Sleep and waking EEG are more sensitive to the radiofrequencies. Is the story concluded and closed? Obviously not. We have a lot of other points open. As a first, we have to look at other type of signals. I just summarized the GSM and the radiofrequency from mobile phone. So we have to look, as some today we'll discuss, I've seen on the program, on the radio basis and, for example, the very dangerous, as the people say, 5G. We have to look at the environmental exposure because we don't live with our phone close to the head for 10 years or for 20 years, but we live in an environment that is rich of radiofrequencies. So we have to look what happened to our brain when we live there every day, every month, every year. We have to look at cumulative effect. I show you just the effect of acute effect, short exposure. What happened when my brain suffers of repeated exposure to radiofrequencies? And then someone said also this, highlighted this aspect, the individual sensitivity in some particularly population. Finally, and this is maybe I try to launch the ball to the who will talk in the following contribution. We have to look at particularly vulnerability of particular groups of people. I worked just few time with elderly and with epileptic, but the real problem is children and adolescents when their brain is not completely maturated, not completely able to defend from exogenous attack. So, thank you very much for your attention. This is my email for every kind of contact, and I will enjoy the rest of contribution. Thank you.
Thank you, Giuseppe. Je vous propose la prochaine présentation, question à la fin à propos éventuellement de cette première présentation. Monica Guxens pour le projet ELF.
Good morning.
Pardon, the ELF project. Good morning, Monica Guxens on the ELF project.
Yes. I'm sorry, I'm just confused. I'm expecting you here with us.
No, sorry. I'm sorry. Yeah,
it's okay.
The little one is ill. She's just here. I'm ill also. Then it's a mess here. Okay, but I will try to give the presentation. Good morning, everybody. I'm very sorry not to be here because I was expecting to come today. I'm going to present the project ELF, Étude longitudinale à radiofréquence et problèmes du sommeil chez les enfants. This is a coordinated project with Joe Biat from Telecom Paris Tech and also Erasmus Medical Center from Rotterdam, and myself from IS Global, the Barcelona Institute for Global Health in Barcelona, in Spain. Then, well, as you already know, there have been major evolutions in mobile communication connected technology devices and uses, but it's important this because particularly children and adolescents are rapidly uptaking all these uses, and then they might be at higher risk of exposure, but we know very little about their real exposure and how this might be potential health effects. Then why sleep? Sleep is crucial for health and development of these children and adolescents for several reasons. It helps restoration, energy conservation, etc. We know that inadequate sleep duration and quality at these ages, but also older ages, leads to adverse physical and mental health. And it has been reported that between 20 and 40% of adolescents have insufficient sleep duration and daytime sleepiness, which is quite a big prevalence. Then what happens in modern life? Since artificial light was introduced, sunset was not longer anymore the end of the day, and we are socializing until late hours, and this means later bedtimes also for these children and adolescents. And with the introduction of the new technologies and all the new devices, blue light, this is also might be related to less and poorer sleep, and this of course is of a public health concern, and we will be interested in studying this. Then which could be the potential mechanism? One of them could be displacement of the time of sleep, because we are using these devices, we don't go to sleep at the time we are supposed to go. It also might lead to mental arousal increase. We are stimulated with the content we see in these devices, and then this impairs that we go to sleep. Then it could also be the blue light that we are exposed from these screens, and it can also be what we are interested in this project of the radiofrequency electromagnetic fields that these devices are emitting. Then this is the main aim of this project. It was to investigate the association between RF, EMF exposure and sleep in pre-adolescents. And we divided in three sub-aims. First, we wanted to look at the cross-sectional association between all-day brain RF, EMF doses and sleep disturbances. Then we wanted to look at the cross-sectional association between all-day brain RF, EMF doses and physiological sleep measures. And then the last point is a longitudinal association between evening brain RF, EMF doses and physiological sleep measurements. For that, we used two birth cohorts in Europe, one in Spain, the IMA project, and one in the Netherlands, the Generation R study. We had our main sample, that is almost 1,600 participants from both cohorts, and we estimated the daily exposure, the dose in the brain of RF EMF exposure, and we collected both self sleep disturbances and physiological sleep measures. And in a sample of them, 335, we managed to also collect daily use of devices to estimate the evening exposure. Then we divided on these three type of exposures, those from phone calls and also screen activities, mobile phone, tablet, and laptop activities. And these we collected because these children were between 10 and 11 years old. We collected with maternal reported questionnaire. And also for the evening, daily, we ask for every day during a week how much they were using the devices after 7 p.m., just the hours before going to bed. And then we also estimate far field exposure using a 3D geospatial model, but also we perform personal measurements in a subgroup of them. Then we divided these three because of the different type of exposure. Then this is the equation. I will not go deep. We can discuss later, but we multiply the SAR with the output power of each sources and the duration that was reported in the questionnaires under the diary. And we have a formula for the day and also another one for the evening. And we did this for each specific source. And we also have an overall exposure. This is the questionnaire we use for the sleep disturbance scale for children. And for the physiological, we use GenActive device that was placed on the wrist for 7 nights. We measure these 4 outcomes. And then we can have an average of the 7 days, but we have daily measurements. Then because we have daily use of devices and daily measurement of sleep, this would be our longitudinal design. This is just the characteristics of the sample. As you can see, is mainly medium and high maternal education population, 50% men, 50% female, and around 10, 11. I will not go in details, but you can see here the numbers. Also, just very briefly, this is the RF EMF dose estimated in the brain, just to show here that when we divide it by sources, phone calls, screen, and far field, you can see how it's much higher in phone calls than as we expected as screen activities, just that you see a bit the magnitude of the numbers. And here are the sleep disturbances and the objective sleep measures. On average, these children were sleeping between 7 and 8 hours per day, which are less than what was recommended by the age. Well, and more or less you can see the order descriptives. Here is the main results. First is the cross-sectional association with the all-day brain dose and sleep disturbances. Is overall null results. We found this association that higher dose from screen activities is related to an increased excessive somnolence of these children. But this did not survive multiple testing correction because we have so many tests. We correct for multiple testing, then this was not surviving. Then this is for the overall day dose and the 4 outcomes on the physiological sleep measurements. And we also found this association between higher exposure from far field and this longer sleep onset latency, but this did not survive correction for multiple testing either. And this is the longitudinal association where we have the daily exposure, evening exposure, and also the daily measurements with the GenActive. And because only 20% of the kids did phone calls instead of having continuous, we have this reference category of null. And those that have a higher exposure from the phone calls are sleeping 12 minutes less than those that have no phone calls at all, and also an increased sleep onset latency. But this the sleep latency does not survive multiple testing, but the total sleep time survives multiple testing. Then this would be our main finding on the project, that higher exposure to radiofrequencies induced by the phone calls in the evening is related to a decrease of 12 minutes of total sleep time on these children.
Sorry to interrupt you. You have about 1 minute left. If possible.
I'm finishing.
Okay,
Yeah.
Great.
Then this is the conclusion that we did not find an association between all-day brain RF EMF doses and sleep disturbances and physiological sleep. We only found this in higher evening brain dose coming from phone calls related to a shorter total sleep time. it seems that evening might be a potential relevant window, which is usually not a study in other studies so far, let's say. But we also need to be careful interpreting the results. First is the first study showing that is a small sample size, 335. And we are also a small effect size, is only 12 minutes less. Is it really 12 minutes relevant? Maybe in a population bias, but we can discuss this. Then we are now, we got funding from an European project where we are going to replicate this study in 2,000 children across Europe and also Japan and Korea. Then to try, this is the aim, to try to replicate these studies and see what we find. And this is published already, Environmental Research, beginning of this year, if you want to see it. And thank you very much to everybody.
Thank you. Thank you very much, Monica. I think we have time for a few questions. Donc, on peut prendre quelques questions.
Docteur Arazi, Alert Phone Gate. Je ne sais pas si ici beaucoup.
Docteur Arazi, Alert Phone Gate. I don't know if many people know, but this project is a structure. Please be brief. Sorry, I haven't mentioned my topic yet. Well, I just wanted to say that IS Global is funded directly by the phone industry via the CAEXA branch foundation, which is one key player in the industry. So I think it's important to mention that the European Commission is funding its surveys through IS Global.
Well,
were you able to understand the question?
Yeah, I understand. It was French. No, I understand French. I don't know. Yeah, sorry. I'm a bit ill. Yeah. No, I mean, La Fundación La Caixa, that is a bank, is a foundation from a bank, is funding 51% of the structural funds of IS Global, which is 30% of our institution. But I can declare this conflict of interest. I had no idea there is a link with the telephonic. I'm sorry, and I can declare this because it's true. But I have no conflict. Like, I don't know how to express this. But my research or it has no influence. I mean, the foundation of La Caixa, whoever, they have no influence of what we are researching at all. I mean, it's completely separated, our research with the funding.
Okay, thank you. Une autre question, et après on passera à la salle.
Yeah. Hello.
Another question, please.
The effect you had, the small effect of exposure with phone calls at night, and I was wondering if you had a control with children calling without mobile phone. Because could this effect just be the time they take to have this phone call? And so it's just the activity and not the radio frequency which has an effect on the duration of sleep.
Yeah, thanks for the question. I try to go super quick. That's the problem we have in this study. If you have any idea, in the next one, we are trying to, because it's very difficult to disentangle the exposure with the use is what I try to introduce in the background. Using the devices might have a lot of other influence on health, like this, the arousal that we are calling, and then we don't go to sleep at the time we are supposed to. But it's very different because it's very difficult to disentangle them because the time spent it can link to both several exposures, let's say. Then we are trying to find a way. I was thinking if it would be possible to try to design a kind of an experiment, like a trial. But I'm not sure. I am still thinking about it. If anyone has any idea, happy to share.
Okay, thank you. Et après, on passera à une ou deux questions en ligne. Monsieur?
Thank you. Then we'll move on to online questions. Please, sir. Jacques Verne, Chair of FACOFAR Santé, Environment and Health of the Living. My question is the first tests for Giuseppe were at 915 megahertz, and then to assess replicability, we moved to 902 megahertz.
Wavelengths in this test. So there is a decrease in the wavelengths exposure. Does it has an influence or not? Est-ce que ça a une influence, la diminution de l'exposition à la puissance des longueurs d'onde?
Well, does it have an impact, the decrease in the exposure time of these wave of length?
In 1999, I think, it was at 915 megahertz, and to check after, you exposed at 902 megahertz. So it's a difference in the wavelengths. Does it has an influence or not?
Well, the length can be a variable to be under control, but the real effect depends on the power of the field. So the length is not so important, because it's important, yes, but when you have a different power, is there the effect? And in fact, they compared different kind of exposure, not basically on different length of waveforms, but they looked at different power of the field. This is the difference. I mean, this is my point of view, but can I be wrong?
Monica, last word about this question, please.
Sorry, this question was for me also?
Yeah, I think so too, I guess. It was also
but it was not about my study, right?
No, it was about...
I didn't understand it.
So, to repeat the question, is that you have not said what was the power of the exposure, of the wavelengths of these exposures.
Okay, oof. Joe Viart is in the room, I think, because I don't remember by heart. If Wout or Joe Viart in the room can answer, sorry, because I cannot remember by heart. I can send it to you if I can send it, because I don't know by heart now everything. It has been published in another paper, and we refer to it. I can send you a huge table.
Yes, Monica, I will.
Yeah, thanks.
Donc, d'abord, la différence de fréquence.
I'm going to answer, Monica. The difference is 1% between 900 and 910. That's approximately the percentage we have. So it's 30 centimeters and 30 plus or less a little something. So this is about power. The assessed power is according to the power radiated from the phones, and we used some atomic models to see how this issued power was distributed onto biological beings. So it depends on how far you are from the base station, and in this case study we analyzed the power emitted by the phones, and these powers through transfer functions, as we cannot assess things in the brain. We looked how this power was distributed in tissues. Thank you very much for this additional explanation. Maybe one online question? Yes, there was a question to which I'd like to answer on wavelength, and maybe the fact that increased arousal in the evening through the use of mobile phones or through the artificial light of screens can be a reason to the difference in the quality of sleep.
I mean, that's the challenge of this kind of studies, because if you use the phone, you have everything. You have the blue light, you have the radio frequency, and then you have whatever content. If it's super stimulating, then what we try to do, like separated calling, because it's calling with the screen time, we were trying to, at least the blue light is not there, because when you are calling, if you put here or where you are with the screen, then we don't think is from the blue light of the screen, but it could be arousal or stimulation of the call, if I don't know, whatever psychological is there, or it could be the radio frequency. Then I think we need to think how we can design studies to be able to separate that. I have no idea. We could set, like experiment that we set a phone that is calling but without emitting exposure, and just to see if it's the calling, the arousal, or the exposure. Yeah, I'm sorry. I would like to have an answer. This is why we try to study, but it's very, very hard.
Okay, thank you. Thank you very much, Monica. Place à la session sur la...
Let's move on to the next presentation. Erwan Stéphan-Blanchard from the University of Picardie, Jules Verne, about NeuroPrem-RF, impact of chronic exposure to radiofrequency electromagnetic fields on neurophysiological development in the preterm neonates. Good morning. Of course, I'd like to thank first the organizing committee for inviting me to introduce to you this survey that was carried out, that was funded by ANSES. I think it's going to be hard for me to fight on some aspects, but this is a survey on the impact of radio frequency electromagnetic fields on preterm neonates. I have no conflict of interest apart from the fact that I have a Samsung phone. So here, well, we can say that these babies have medical complexity due to their prematurity, of course, with limitations that are of significance and for which there is a need for medical monitoring and care that is complicated and ensured through a certain number of tools and high technology developments, which can in turn expose these children, hospitalized children, for prematurity reasons to radio frequencies. A majority of these devices communicate between themselves through via such waves. So there is higher vulnerability of these children. It was demonstrated not long ago, especially for the tissues of the brain. Here we have a study carried out by some experts that shows the level of exposure of children and the impact onto not only the brain but the whole body, given the size of a premature baby, which is the size, of the head of an adult. Some other studies, surveys were carried out. Only one dealt with radio frequencies, one in Spain by Calvente, which measured environmental measurements in hospital environment, and they demonstrated the existence of radio frequencies from radio emissions. So if you have a an X-ray facility, it impacts the environment, the hospital environment. Then a second survey was carried out for physiological impact, but only on low frequency fields. It's difficult to read here, but here it showed a variability, a decrease in the variability of the heart rate, as well as other aspects, but this was just about switching off incubators for premature babies. So on, you have less, you have more radio frequencies, off less. We demonstrated, then one survey had a twofold objective. First, to demonstrate the knowledge on exposure modalities for these premature neonates. We carried out in Amiens some experiment, and then we carried out some neurophysiological investigations on three aspects: this quality of sleep, nervous brain activity, and hemodynamic activity. And we realized and we carried out the individual exposure of each baby to see whether there'd be a difference between the level we find in the hospital environment and the level to which they are exposed in the various departments, hospital departments. Now, for the environmental level, and this is very much a summary, but you can find the results in the article that you have the reference of on the top right-hand side of the slide. Well, the structure is not of interest to you here. It's just the map of the neonate department and intensive care services with the way radio frequencies share out. And on the graph here on the right-hand side, we analyzed the levels assessed according to the areas. There are two areas, the staff areas. These are the islands, central islands that you can see on the right and left of the mapping. And then we had the children's rooms. We compared also the difference between night and day, and you have the results here on the graph on the right-hand side, with the levels higher in the staff area than in the rooms of children. And you will see that this is due to the communication devices used, mainly the mobile phones. We also carried out within our lab an assessment of the radio frequency emissions of the medical devices. It's very quick. None of them is actually emitting radio frequencies. If we have some values, it's because it's the limit of detection of the dosimeter, 0 to 0.5. And then here I present to you the protocol for physiological investigations. Globally, we studied neonates that we recruited between 26 and 30 for weeks of pregnancy. A normal pregnancy is 41 weeks. And then we kept track of their development with a dosimeter for 3 weeks. We had ongoing exposure with assessment every 2 minutes. And after 3 weeks, we had a polysomnography of 20 hours, during which we had assessment of the brain activity, the heart activity, and also oxygenation of the brain through infrared. The survey was carried out onto a greater number of children. It's a bit difficult, of course, to recruit premature neonates, especially during the COVID period, as people were wary of the medical world, and this impacted us very much. We had a majority of girls, which is quite frequent for neonates. Sorry. So the small difficulty that we had is that we used two difficulties. The first is the median, that is what we call P50, the values of exposure in the environment, but we also use the 99 percentile, which means results that show only the highest values. And what is interesting when studying these two factors is that the source at the origin of exposure is different whether you look the median or the percentile. When you look the median, that's the top diagram, is related to mobile phones and CCT, but when you take the highest values, that's a mobile phone, with the highest values. You can read the values here. When you took the median exposure, it's 0 to 0.2 volts a meter, and when you take the percentile, it's multiplied by 10. These are very low values, but they are of interest to us. And what is remarkable is that there are many fluctuations between the patients, but also within each patient. Here you have the result for one same patient to show to you the variability in the level of exposure. And the idea is that for 100% of patients, we have transitory values that can go beyond 1 to 3 or even the saturation of the dosimeters we used. You have only a couple of minutes left. Well, it's going to be really hard. I'm sorry. No, it's me.
Globalement, l'idée...
So let me show you the outcome of these physiological surveys. They are very difficult to notice. We saw an increase in the non-determinated sleep. I don't know if you know this notion. It's non-determined because it's not well structured, because the children are not mature. And we have here also an indicator for the poor quality of sleep of the child because of a changing environment. The most important to you, I think, is this one. It's a decrease of the delta waves, EEG, to the profit of alpha for children who are most exposed to radio frequencies. Now, for the autonomous nervous system, data we have is very varied, and it's difficult to identify some proven impact. Globally, we assess some extremely low levels of exposure, 0.02, 0.008, but strong heterogeneity with the values you can see here. That is peak values for all children, and we try to analyze the impact onto children for these values, and we didn't observe anything, and we have very low values, so I'm not going to comment further. And we have the next step of our project, which is a project funded by several partners. We still have a bit of time for a couple of questions in the audience. Mike, please.
Merci. Oui, dans une diapo, vous avez...
Thank you very much. In on one of your slides, you mentioned mobile phone, but there were two sections, DL and UL. UL is direct and DL is for download. That is whether you send out information to the radio repeater, or whether you get information from the radio waves from the radio repeater. I don't know how this happens, but the parents think that the music favors the development of their children, and they put their phone there to actually broadcast some music. Welcome to the pediatrics world. We let them do, because this is interesting for our survey. I'm just trying to answer future comments, but of course, as researchers, we don't interfere with the practices of parents. Thank you very much. My name is Rafailovic. I am in charge of AZT, which is an association. We're looking for white areas that is deprived of such waves, radiation. So you observe the deterioration of sleep for very, very small babies, for level of radiations that are extremely low. This is what is interesting to us. We were below 0.6 volts per meter, which is the threshold for association. So that's far below what authorities are defining. And you're telling us that at these very low levels of doses we already have impact. Yes, thank you for your comment. The problem is that in the current context we cannot draw conclusions. Yes, we observe impact, that is proven impact, as there are physiological effects, but will they have an impact in terms of health and the development of the child? I don't know, which is why it's interesting to have a multi-dimensional survey investigating different aspects with labs in Lyon and other areas. But given the conditions that we carried out our work, it's very difficult. But yes, it is quite thought triggering. I'd like us to take some questions online. One that is very much related to the previous one. One person is telling me that they noted that the intensity of the fields mentioned in the state-of-the-art devices is much higher than the ones mentioned in your surveys. Yes, in the Calvente, they're just radio waves. If you have a radio repeater closely, this explains that. But this is very recent. So from the very beginning, they have an approach whereby they have, of course, Wi-Fi waves. They have the mobile phones of the patients or the parents of the staff, but otherwise the other devices are all operating through cable networks. And in some rural areas, such as outside Amiens, there is only one radio repeater, which is quite far from the hospital of Amiens. And in Lyon, for instance, you have 16 around the hospital, which is why we're checking other territories of the country. Thank you very much. We're going to move on to the next presentation to respect the schedule, to abide by the schedule. So for the next presentation, we have the SPUTNIC project presented by Marloes Eeftens, from the Swiss Tropical and Public Health Institute, Switzerland. Thank you very much.
Good morning, everybody. My name is Marloes Eeftens. I will be talking to you today about our project SPUTNIC. Oh, sorry, this is, I think, the wrong presentation. I have another one this afternoon. I think I'm supposed to be talking about the SPUTNIC project this morning. If you could flip the slides so that we stay on the same topic. It's okay. I had 2 presentations today, so I know it's confusing.
Question en ligne? Ouais. Ton micro marche pas.
Est-ce que vous avez éliminé d'autres facteurs, enfin objectivé et éventuellement éliminé d'autres facteurs comme par exemple l'exposition au bruit?
Alors, pas spécifiquement le bruit pour le coup. Par contre, évidemment, on a étudié un très grand nombre, l'influence d'un très grand nombre de facteurs confondants, notamment cliniques, les pathologies, les médicaments.
Right, sorry. We did not study other environmental factors, but we did study a lot of confusion factors.
Real-life markers of phone use and cognitive performance, health-related quality of life, and sleep. This was a collaboration called SPUTNIC for a study panel on upcoming technologies to study non-ionizing radiation and cognition, funded by ANSES. And I will be talking about the part that is the panel study that was done in collaboration with the University of Besançon. So we studied the real-life short-term effects of RF-EMF markers on cognition, health-related quality of life, which have not really been conclusively studied in the past. And particularly one project that we had completed a couple of years prior to starting this one had concluded that there was a small effect, and in fact it was a lateral effect where we saw that left side phone users scored slightly lower on verbal memory tasks, and right side phone users scored slightly lower on figural memory tasks, which we thought was an interesting finding. This was a study which assessed the health or the cognitive performance at 2 different time points. So we were kind of interested to see if we could replicate this in a panel study setting. So we set out to study 3 different markers of RF-EMF exposure: cordless phone call duration, mobile phone call duration, and screen time. So as mentioned, to try our best way possible to disentangle these different factors. And in addition, we studied also 3 different markers of health: cognitive performance, sleep quality and quantity, and health-related quality of life. So you can see there's quite a few possible relationships between these different things. So to this end, we recruited a study population of 121 individuals. They had to be smartphone users, otherwise there wouldn't be much to study. So this was 58 people from Basel and 63 people from Besançon. This is just the flyers that we put out to try and recruit these people. And just some characteristics of the study population. We had a slightly higher representation of females and more highly educated people, I would say, who were willing to participate in the study. Most of them were employed as well. How did this study look like in practice? So it lasted for a total of 12 days. On the first day, they would get a visit by our study assistant, who would introduce them to the study and obtain also the informed consent. And then for the next period of 10 days, we would follow them up using daily questionnaires, trying to assess exposure to these different mobile phone markers. We also measured their physical activity using a Fitbit. The health-related quality of life was obtained by a mini questionnaire, and then we measured also cognitive function using online tests. And then at the end of this follow-up period, the materials would be collected by the study assistant again. So, We had tried to use an app for this study. This was unfortunately not so successful, so this study then relied on the markers that we had assessed in the daily questionnaires about RF EMF exposure. So here, we decided to focus on the 4 hours before taking the test about the health-related quality of life and also the cognitive tests. Then the markers of health, the cognitive tests, I will show you in a minute. The sleep quality and quantity were measured using a Fitbit activity tracker, and the questionnaires on health-related quality of life were assessed on a Likert scale from 0 to 10, where people were able to let us know how they felt that day. So these are some of the cognitive tests that we used. I will just highlight 2 of them. This one is based on the strobe color word test, where the word red is written in blue, and you're supposed to use the word that reflects the color. And this is a spatial test where you're challenged to follow a square that jumps around and trace it again. So, as for statistical analysis, this is a mixed modeling study. So the differences between people are not as important as the differences within people. So we corrected for the time variant confounders listed here on top. We only analyzed data from people who had participated in at least 3 assessments. All this was done in R, and we had mixed models with random intercepts for the study participant to take account of the different baselines that people have. In terms of associations with cognitive performance, there were 24 statistical tests done, of which 2 showed a significant association, particularly the 10-minute increase in cordless calls. In cordless calls, having a significant decrease on the rotations task, and the 10-minute increase in mobile calls having a increase in the spatial span task. So in conclusion, I mean, we had 3 spatial and 3 more verbal related tasks. We can't really see a very convincing and like a pattern that holds up between all of these different tests. And also just that 2 out of 24 tests were significant is compatible with the possibility that these are actually chance findings. Also, when we looked at the results laterally, phone use split out by phone use on the right and phone use on the left. Again, some signals jump around, but it's not very consistent in a way. So when we looked at the effects on sleep duration and quality, here we looked at the time in bed, total time asleep, sleep efficiency, the 4 different phases of sleep that Fitbit recognizes, so deep sleep, light, REM, and lying awake. Here we saw absolutely no effects at all, neither for cordless phone calls, mobile calls, or screen time. And our last health endpoint, health-related quality of life, is really where we saw, in a way, the most consistent associations. Some of them borderline significant, others more convincing. Not significant between cordless or mobile phone calls and any of these health-related quality of life indicators. as you see here, none of these are really significant. But what we saw quite clearly is a 10-minute increase in screen time leads to a decrease in fatigue. So people felt less tired. A decrease in mood, people felt less good, and an increase in stress levels. And these are, I think, the most strongest results that we have seen. Oh, can I go back? So what's really interesting here is that it's not so much the call time, so what is related to the actual high RF EMF exposure, but the screen time that seems to be most associated with these health-related quality of life effects. So in conclusion, there are inconsistent associations still between phone use and cognition. We did not find anything really tangible here. No associations for sleep duration or quality at all, and we did find some adverse effects of screen time on health-related quality of life. These have also been previously indicated by other studies, so this is kind of confirming those results. And as I pointed out before, it's more the association with screen time in this case of this study than call time that seems to be most of the association. And with that, I would like to thank the project team, our funders ANSES, and just the ethics declaration as well. This was obviously approved by them.
Thank you. Thank you very much. Nous avons le temps pour quelques questions de la...
We have time for a few questions.
If I could not understand if you measure the quality of life before the experiment or the observational period, or only during and at the end, because it could be, of course, that people with a lower quality of life to start with were higher users of mobile phones. Is that sort of clear?
So this is a mixed modeling study, which means that we follow a number of individuals in time. And so they all have a baseline. Everybody has a different baseline. Also for quality of life, some people have a lower, some people have a higher baseline. What we study in this study setup is really the variation in time. So wherever that person started off, how does their fluctuation of their daily health-related quality of life fluctuate with and in association with these different exposure metrics? So in a way that personal differences are offset in the model. Yes.
Ok. Une autre question, Bila?
Oui, Eric Vindimian, président du...
I'm president of the dialogue committee at the ANSES presentation.
I'm wondering about the screen time. I guess it might depend on what you're looking on the screen. If you're reading scientific papers on the screen that you could read on a printed paper, and you compare it to just playing a stupid shoot-'em-up game, it might be different on cognitive effect. So do you record the type of activity which is achieved on those screens, and not only the time?
Yeah, I think that is a question that interests many of us, because I'm with you. I think it has a tremendous effect what exactly you're looking at on screen. Now, whether it would it would pass the ethics board. Let's leave that in the middle, because we would essentially be surveilling people quite intensively if we were looking at what exactly they were doing on their mobile phones. That aside, I think, yeah, I mean, one of the thoughts that we had when setting up this project, as I mentioned already briefly, is that we would actually use an app for this. I could imagine that such apps, and I think they are being developed in some other projects as well, to try and get more of a grasp, maybe not on exactly the screen content, but are people, for example, reading news websites or on Facebook, or as you said, just listening to music or playing games. This is all, yeah, maybe then without recording the content, it would be possible to at least diversify it a little bit. But this was not possible within this study, unfortunately.
OK, thank you. Des questions en ligne, peut-être, une ou deux questions, puis on s'arrêtera là.
Does the time spent on a screen did increase finally stress, or vice versa? And there is a comment to this question. Does a stressed person you are using more screens finally?
That is also a good question. So reverse causality is definitely one of the limitations of this study, right? So I'll have to acknowledge that you don't always necessarily know if it's the stress that causes the doom scrolling or if it's the doom scrolling that causes the stress. And quite often, I would also argue it's a vicious cycle.
OK, thank you. Thank you very much.
Stepping from that, I would say that in your presentation show more or less that there is no effect in terms of cognition and behavior. Could then we assume that this would be the case on chronic exposure of children, of continuous exposure, 24 hours a day? This is my question. And if I allow, I have another comment. Another speaker. Thank you very much.
I have no answer. Probably yes. The effects are not evident because we have no continuous, not chronic exposure. But behavior is a very strange, as shown also by the colleague. Behavior show very variable effects. So someone is sensitive, someone is not. So when you put together the data as their data, you don't find any kind of effect. It depends on the chronicity of exposure, maybe yes, but I'm not able to answer.
Then we have to do studies on chronicity
yes,
of
it
effects.
should be done. It should be done.
And you cannot reassure the people that there is no problem.
No.
Kid, especially with the children.
My discussion was as a kind of summary of the existing literature. I'm not convinced on one side, on the other side. I just read and assess the reliable and consistent results and data.
No. I appreciate your approach.
Thank you.
But I would say that we need to be on the precautionary side. I mean, we need to advise, and then I go to the next speaker who was dealing with the preterm kids. I would say that in Cyprus we did a small pilot project in hospital, in pediatric hospital, trying to reduce the exposure via disconnect Wi-Fi's and advising people how to use their mobile phones in this, especially the parents. I heard that it is very important that the music is good for the child. I agree. But please advise the parents that they should use their mobile on flight mode next to the preterm children, and not only. So there are ways, so we need to combine the science that we have so far, which indicates some effects, are not very sure, but we need to do more studies oriented towards children's sensitivity. And this is missing these days. And on the other hand, in the meantime, we should approaching the issue by advising the people how wise can you use the technology with less effect, with less exposure. We don't say no technology, but we can use it in a safer way, and this is missing from the policies at national levels, at least. Thank you.
Any comments? No.
I agree.
Okay. Monica, any comment about this discussion? No? No? Okay. Oui. Question là au milieu
là. I am dealing with adults. I'm a neurologist to Erwan Stéphan-Blanchard about sleep and the modification in the quality of sleep. And you didn't come up with an answer for adults. There is very little doubt to the fact that fragmenting sleep has an impact. I guess it's the same for children. So modification in sleep quality has necessarily harmful impact on the development, the neurological development. I don't know whether these results were actually repeated by other teams, but I think it's fundamental to work on them. And if they're mainly used, these devices, by carers who don't need them, they should be banned completely, given the state of knowledge currently. Well, your example is a bit caricatural. Yes, well, I meant it to be. There are a huge number of physiological criteria, statistical, medical, which have to be taken into account and prevent us from saying that there is evidence of this, and that should be taken into account when caring for children in hospital departments. It's our role as researchers to pay attention to many aspects, many of which I couldn't tell you about today. But in particular, the fact that, I don't know whether you observed that, but in terms of the structure of sleep, the P50, that is the exposure, we sometimes use it, sometimes we use P99. But there is no difference whether we use self-dependent sleep or that we have no consistent result. What I showed is the one that was most telling, that is the observation of fragmentation of sleep. But out of 29 patients, we have a few only, as you could see. But I would like to have a weighed answered, so that we have further studies so that we confirm or not. And when it's confirmed, we take the necessary steps. Yes. A question and a comment to Mr. Blanchard again. In your presentation, 2 articles on the rate, the specific absorption rate at 2008-2011, quoting Mr. Viard. Mr. Viard at the time was head of Orange Labs, the mobile phone operator. So I'd like to know who carried out this exposure protocol, and a little complement, we can look quickly at the slide of the SPUTNIC study. Once again, we see Mr. Joviard quoted here, and I'd like to repeat that he was working for a mobile phone company in 2015.
Après, les études de M. Viard, voilà, je ne connais pas le contexte.
Sorry, there was a channel problem. Well, I don't know the context to justify clearly Mr. Viard's presence. I don't know him. Well, do we have further questions in the room or online?
Merci.
Thank you. We're just getting out of a health crisis. Well, we're not really out of it, actually. And looking at these data and the data that ANSYS has been publishing for 10 years or even more, wonder about a possible scandal, health scandal impacting children and future generations. We have here the presence of the World Health Organization, and my question is, what is the precautionary message you would send out to the population? We have ads, posters in the cities, many means. I've been working for an NGO, WCF, for 4 years, which publishes information leaflets for pregnant women who ask for information. And then what is the role of health professionals who are supposed to be a relay to protect health? Here we see hospitals who sometimes are increased exposure areas. This is quite worrying.
Okay, very shortly.
Okay.
Very shortly. The question is about the public health messages for the general population, especially pregnant women, future parents. So, what kind of campaigns you can develop to inform them? We know that, for instance, in 2008 in France, there has been a call to reduce exposure to mobile phones for children. So we are now in 2022. And the second question is the role of health professionals. They are supposed to protect health. And here in hospitals, they are also in facilities where the exposure could be very important for children. So these are some perspectives. Thank you.
Okay. Someone would just
I try to say my point of view. As a spot, I can just say, let's continue to do research to better understand what happened to the brain. And let's help the scientists to have funding to do it. And then educate both parents and children to a ethical, moral, cognitive use of technology. Technology is not bad or good. Technology is in our life. So we cannot say, okay, from tomorrow technology is off. We have to use it with the head and also with the heart, if you want. This is my spot.
Any other comment? Monica, you want to comment about the big questions? No, it's quite complicated.
Can you hear me?
Yes.
Yeah.
Yes.
No, just shortly. I think the devices in children and adolescents is not only about radiofrequency electromagnetic fields, it's about they might misuse it. I mean, that a child at 10 in the night is looking at the phone in bed, that's not recommended. And I think I agree. We should give also this message and public health and also like pediatricians and everything. I think a proper use of the device should be the recommendation. The same that has happened with TV use in the last 20 years, then I agree.
Okay. Thank you, Monica. Oui.
Maybe just a small comment to add here. It's actually also as parents who are setting the example for our children, and by sitting at the dinner table there's a term for this, phubbing them. That means looking at your phone instead of having a conversation about what the day was like. I think there are other reasons, as Monica said, than RF-EMF to limit our phones to conscious use, and to also, as parents, set the right example for our children, because this happens at the home, and this is so important. And it's not like you can get a social worker to be at your home policing you. So it's really this consciousness that in society needs to be developed by parents, teachers, and if we do that, then I think with children as well.
Thank you. Thank you very much. Olivier, une ou deux questions et on termine vraiment notre session.
Olivier, one or two questions from the net. Well, a general trend. They're asking to make the distinction between environmental exposure and mobile phone exposure. And there was one specific question to Giuseppe.
Explain the impact of radio frequencies on EEG. And a related question, could there be an influence of a blood flow in the brain, in that mechanism?
Just a first sentence. I'm a psychologist. I'm not an expert of dosimetry. So, say this, I think that one of the possible mechanisms of action is the increase of excitability of cortical neurons, one of the possible mechanism of action. So, to respond, my answer to the first question is this is one of the way to follow. With respect to the cerebral blood flow, there are some studies. I never used cerebral blood flow, just with a study in functional magnetic resonance imaging, but never PET or something like that. And this could be explained on the basis of an increase of excitability. So if you excite some neurons, those neurons go faster and attract more blood, more or less. This could be a possible mechanism of action. But please, excuse me, I'm just a psychologist.
Ok. Je pense que c'est bon, on peut terminer cette...
Well, I think that we can now conclude this session. Thank you very much to our speakers.